This is the homework for 230, 231, 232, 233, and 234. Problem 230a. One of the lines at right matches the equation y equals 2x plus 3, and the other matches y equals 2x minus 3. Which line matches which equation? So I did growth triangles for each of the lines. That's the rate of change. And then I highlighted the y-axis, yellow, and then that's where you will find the y-intercept, the b part of y equals mx plus b. And so for line A, we know it's positive. It's sloping towards the positive x values. So we know it has a positive slope. Its y-intercept is at -2. That's where the line crosses the y-axis. So here we have -2. And then the rate of change from any two points where the line is going through the lattice points, so we have this point and this point, has a rise of 2 and a run of 1. Delta y is 2, delta x is 1. So we have 2x minus 2. So that is line A. For y equals 2x plus 3, well, the plus 3, you look on the y-axis, and the one that has a y-intercept of positive 3 is line B. So line B is 2x plus 3. And the rate of change, I could choose any 2 points. Rise of 2, run of 1, 2 over 1. And you can see that that's constant rate of change. Rise 2, run 1, rise 2, run 1, rise 2, run 1. Part B, Yoshi wants to add the line y equals 2x plus 1. So we know the y-intercept is at positive 1. So we go to, here's the origin, positive 1. So we know our line's going to go through there. And it has a rate of change of 2 over 1. So the slope is rise 2, run 1, rise 2, run 1. The second part of B is where would it lie on the graph? It would lie between line A and line B because its y-intercept is between -2 and -3. And one thing that you notice, that they all have the same slope, 2, 2, and 2. Well, when lines have the same slope, that means that they are parallel because they have the same rate of change. Rise 2, run 1, rise 2, run 1, and they all have that rate of change. So that means that these lines will never intersect because they are all parallel. They all have the same rate of change or slope. The only thing that's different is where they lie on the graph because of the y-intercept. -2, positive 3, and positive 1. For part C, where would line -2x plus 1 lie? Well, this has a negative slope, so we know it would be slanting to the left towards the negative x values. The y-intercept is at positive 1, so that's where I'm going to start at. Here's the origin, and go to positive 1. And it has a negative slope. So -2, positive 1, -2, positive 1. Or I can go +2, -1, +2, -1. Because +2 divided by -1 is the -2. Or -2 divided by +1 equals -2. So -2x plus 1 has the same y-intercept as y equals 2x plus 1, but it has a negative slope. So they're going through the same point of the y-axis, but one has, line D has a negative slope, line C has a positive slope. Problem 231, you need to create a scatter plot. Problem 231, you need to create a scatter plot on graph paper using the data from this table. You're going to draw a line of best fit that represents the data. So I plotted the points from the table. I have the final percent as the dependent variable and the AP score as the independent variable on the x-axis. When you're doing a scatter plot and a line of best fit, your line of best fit is used as a prediction. So what I would do is I would try to create the line of best fit where half of the data is above and half of the data is below. So I'm trying to like thread a needle through all the data points. So you have, again, half above and half below. Now we're going to use the line of best fit to predict the final exam score of another student who scored a 3 on their AP test. So here's our line of best fit, and here's an AP score of 3. We come up to our line of best fit, go to their final percentage, and it's going to give us an approximate value. So a student who scored a 3 on their AP test would likely have an approximate score of 79% using the line of best fit. Your line of best fit may be a little steeper or a little less steep. So depending on how you put your line of best fit, your final percentage may be a little different. But again, remember, it's just an approximate value. So we're going to multiply these two terms. And you can only multiply when you have like terms. So we have 6 and 4, and then we have exponents with the same base. We can multiply those two. So 6 multiplied by 4, and then 10 squared multiplied by 10 to the 5th power. 6 multiplied by 4 is 24. And remember, when you multiply exponents with the same base, you're adding the exponents. You have 2 10s that you're multiplying together and 5 10s. So 2 plus 5 is going to be 7. Now, when this looks like it's in scientific notation, but in order to be in scientific notation, the A term has to be greater than or equal to 1, but less than 10. Well, 24 is definitely greater than 1, and it's greater than 10. So we have to decrease this value of 24. And so we do that by dividing it by 10, and that will move the decimal to the left, one place value. But if you decrease this, if you divide this side by 10, you're going to have to multiply this by 10. So we're going to add another 10 to this. So 24 becomes 2 and 4 tenths. 10 to the 7th plus 1 is 10 to the 8th. Problem B, we're going to go ahead and multiply like terms. So we have 1 and 75 hundredths multiplied by 8, and 10 to the negative 2nd power multiplied by 10 to the negative 8th power. You can multiply like terms if they have the same bases. So here, 1 and 75 hundredths multiplied by 8 is 14. And then multiplying exponents with the same base, you add the exponents, negative 2 and negative 8. So you determine, do you have more negatives or positives? Well, these are both negatives. So you keep the sign that you have more of. signs are the same, you add them. So then we get -2 and -8 equals -10. Not in scientific notation, 14 is greater than 10, so we're going to divide this by 10, so we're going to move the decimal place to the left one, so it's going to be -1. Well, this is going to be adding 1. So -10 plus 1 is -9. So 1 4/10 multiplied by 10 to the -9th power. Problem 2, 32C, we're dividing in scientific notation. We can only divide like terms. So we're going to go ahead and divide 9 divided by 4. And then when you're dividing exponents with the same base, remember you're subtracting them. And this division bars remind you to subtract 5 minus 7. Well, 5 minus 7, well, 9 divided by 4 first is going to be 2 25/100. 5 minus 7, we have more negatives than positives, so you know it's going to be a negative. Signs are opposite, so you subtract. 7 minus 5 is 2. And this is in scientific notation since the A term is greater than or equal to 1, but less than 10.